A lift of mass m is suspended from a cable. There's the tension force. Here's the weight force. And then we're told the lift descends with a downward acceleration of a, so acceleration is this way. A frictional force F acts on the lift, so if the lift is descending and we have a frictional force, the frictional force will always oppose motion, so there is a frictional force here, so I'll call this T plus F. And then we're trying to work out the tension in the cable. So to do this, we have to get an equation of motion. We have to use the equation F is equal to ma, so just bear in mind this F is not the same thing as the friction. F represents the resultant force on the object. We know the object, the lift, is accelerating downwards. If it's accelerating downwards, the resultant force must also be downwards. And that resultant force will be mg, the downwards force, minus the upwards force. So this will be the overall downwards force. And if that is the resultant force, then this should be equal to ma. So this is the resultant force, that is F. That should therefore be equal to ma. So the mass in this case is capital M, acceleration is a. And then we can rearrange this equation for T. So T is equal to mg minus F minus ma. Just basically switch these two things around. And what option is that? So mg minus F minus, okay, so we have m is factorized in this case, so I'm going to do the same thing. So T is then equal to m multiplied by g minus a minus F. That was factorizing these two terms. And that gives me D.